if it's part of the homogeneous solution, then you can't use it?
Not exactly. Just like here I have my review, and this is a table from the textbook. Basically, with the method of undetermined coefficients, if you have the g function is, right, this g function is a polynomial, then you have a polynomial of the same rank, I think that's rank, unless you have this power here is part of your solution. Then you multiply it by t raised to whatever power is necessary to make it so it's not redundant. So you still use it. You just have to do the same as you would if you had a repeated root.
Right. And I guess my question, and that's kind of where I was going with it, and then my question would be, how can you just multiply by t an infinite amount of times until it just works?
Well, a key is it's not an infinite amount of times.
If necessary.
And the philosophical answer, I don't have.
Yeah, for this, all you just need is the first and second derivative.
Well, I mean, you can go through the work and see that it works every time, but that's not a proof, right? And so I don't have the answer of why it works every time. But, and the same is true no matter what type you have. If you have an exponential, if it's a repeated root of one of your homogeneous solutions, then you multiply by, t raised to the 1, if that will make it not repeated. If it's still repeated, then by t squared and so on. Answer the question? Without giving you the why? Because
it still doesn't really make sense that like I guess maybe it's because in class she didn't really tell us that we can do that. And so like it took, Aaron and I did it together, and it took us like an hour just to figure out that we can do that.
I also think it's just the wording of the book. I'm trying to find the page here.
It's right underneath this. Of course, this doesn't say what page it's on. 139 in the old book, because I copied this off the internet.
182.
182, okay.
Just 1 second.
But right underneath it says, where S is whatever power, parentheses 0, 1, 2, ... is necessary to make it so you don't have a repeated root.
It feels like that. I don't know, it just feels like you're just doing whatever you want,
Well, I'm the wrong person to answer this because I'm like a physicist. We're very practical about our math. And we're like, hey, that's what works. Like I was telling Nathan, differential equations, you're just going to learn trick after trick after trick, right? I know you're a math major, or at least second major, right? And so you probably want a little more meaning behind it. I'm going to review for a few minutes and then give you the quiz. So first reviewing homogeneous solutions. You can find homogeneous solutions if P of t and Q of t, and actually are constants. Obviously, in real differential equations out there in the world or later on this semester, you will have situations where P of t and Q of t are in fact functions of t. Otherwise, they would have just put A, B, C like they do in a lot of the problems. So we can find the homogeneous solution if P and Q are constants. If we get real roots, well, let's just start with, let's say we have an equation, AY double prime plus BY prime plus CY equals 0. I put equals 0 because the homogeneous solution is the solution when it's equal to 0. How do I find the roots of this? Okay, it starts with an assumption, which actually goes with 3-5, even though you learned it first, that the solution has the form of e to the RT. So you making that assumption for this type of problem. Because, well, if you didn't take physics 251, you took 151.
No, this first one.
So in that class, I just say it has this form, now let's find it. So if you take the second derivative and the first derivative, y prime is equal to ry, y double prime is equal to r squared y. And so you plug those in, factor out, and you have a r squared y plus b ry plus cy equals 0. So ar squared plus br plus c times y equals 0, which is true for A, the trivial solution, that is y equals 0, or if the thing in parentheses is 0. And so then we just took AR squared plus BR plus C equals 0, and we find the roots. And you've all had enough math. I'm not going to go through, like the quadratic to find the roots. If you have real roots, then you just have, well, how many roots are you going to have for second order differential equation? Second order, you have 2, one for each order. So you're going to have 2 roots, and so then your homogeneous solution is just a linear combination of those two. So your homogeneous solution would be, and your textbook uses some different nomenclature than I used. So all I can remember right now is we did y homogeneous is equal to C1 y1 plus C2 y2, where y1 and y2 were e to the r1t and e to the r2t. So that's how we did it if we had real roots. What about if we have imaginary or complex roots? Well, actually, I have them separate. What do we do if they're imaginary roots?
You put it in the form of sine and cosine.
Sine and cosine. Because according to Euler's formula, e to the I theta is cosine theta plus I sine theta. And then the book goes through a little rigmarole to say, and when you have, 2 solutions, if your root, if you're dealing in the real world, you just can rearrange it to have reals for C1 and C2. So you have, your solution is y1 is C1 cosine, whatever the root is, without the ist, and y2 is C2 sine, same thing. If it's complex, you're just combining the two. Remember, a complex value is a real plus an imaginary. E raised to the real plus imaginary is e to the real times e to the imaginary. And so you just have the e to the imaginary part gives you the sinusoid, and the e to the real part gives you something like you had the first time. Repeated roots. This is what Mr. Carlson asked about. If you have a repeated root, then you just multiply one of them by t. So for instance, if I had in this case that R1 equals R2 equals 5, then my solution would have been y1 is equal to e to the 5t, and y2 would be t e to the 5t. Why? I don't know. It happened in this classroom before, right?
Dr. King has a lot of trouble with this.
I had that happen one other time where things were just skipping. Okay, method of undetermined coefficients. The thing that I'm going to give you a quiz on in 2 minutes. You first have to find the homogeneous solution. So you go through the steps we just did to find your homogeneous solution. Then your particular solution is simply based on the form of G. So if you have a polynomial like, a double prime plus by, or ay double prime plus by prime plus cy equals t squared minus 5. Then you're going to have your particular solution has the form of a0t squared plus a1t plus a2, a polynomial of the same rank. But if your homogeneous solution had t squared in it, which it's not gonna from what we have, right? It's not an option. Then you would multiply everything by a t. So your polynomial, if you have your highest order is part of your solution, then your polynomial is going to go from one higher order power of t down to t to the 1. It's not going to have a constant term in the polynomial. Or if you're an exponential, which is the most common case so far, right? Then your solution, this is polynomial times the exponential, so it still has the exact same polynomial treatment, and then e to the alpha t, where alpha is whatever you had in your G.
What is S in that equation?
So S, that's what we were talking about at the beginning of class. S equals 0, 1, 2, blah, blah, blah. whatever
You
is
can only do it
necessary.
twice.
I thought you couldn't go beyond 2.
Just like order.
For second order, right? For second order, you can't go beyond 2.
Yeah.
But for higher
In this
orders,
situation.
Yeah.
So it should only go to 2.
to disambiguate. That is so you don't have your highest power here is the same as your solution.
And N is just the power of the like.
And
The
it's counting
order
numbers
of your-
starting at the highest power you had up here. So that this piece of n means a polynomial of n3.
Okay.
And so you go, that's your highest power here. Okay, this is the end of my review, so it's time to do the quiz. Unless you all want to clamor, wait. In which case we don't get anything done in class. Okay, I guess you're allowed to have your homework out. And I cannot leave the screen on this because that would be a little too much. Did I not give you one?
It'll be fine.
Well, I guarantee he'll do better with the paper than without. Now let's go over it, and don't be alarmed at how quickly I do it. I spent the better part of yesterday going over all of my differential equations. So we're going to take this. We have the form of y equals e to the rt. So taking the derivatives, we're going to have r squared plus 6r plus 9 all times e to the rt equals 2e to the minus t. Well, we're doing the homogeneous equation, so equals 0, right? Because first you have to solve for the homogeneous. So the roots of this is r plus 3 squared equals 0. Therefore, r equals minus 3. And they're repeated roots. So because they're repeated roots, I have y1 equals e to the minus 3t. y2 equals t e to the minus 3t. What we were talking about before class, that t raised to the first number that will make it non-ambiguous. Now that we have that, we finally find our y particular, which you use as capital Y. And it's going to have to be some constant times e to the minus t. Now, because e to the minus t was not either of these, I don't have to do any other modification. And so then if I take the derivative of that, y prime is equal to minus a e to the minus t, or minus y. Y double prime is equal to a e to the minus t, or y. So now I just plug this into my original equation. So I would have y plus 6 minus y, right? Because y prime was minus y, plus 9y equals 2e to the minus t. I did it this way just because it's easier for me to do the math. 1 plus 9 is 10, minus 6 is 4. So I have 4y is equal to 2e to the minus t. So that's 4 times my a e to the minus t equals 2e to the minus t. Well, at this point, by inspection, my math teachers used that a lot when I was in college, I know that a is going to have to be 1/2, so 1/2 of 4 is equal to 2. So the left side equals the right side. I mean, this is what we would do in any other class I would teach besides math. And so then we have y is equal to c1 y1 plus c2 y2 plus capital Y. So that's c1 e to the minus 3t plus c2t e to the minus 3t plus 1/2 e to the minus t. So if you made some slight errors, it's good to see how it's done. The whole point of this is so you can learn. Of course, if you did it right, then you didn't have a lot of learning to do because you're all right down with it. Any questions about the quiz? Nope. Then back to the lecture. And hey, I've still got 20 minutes. I can do this. So our new method today. When I saw the method I was teaching, I was so disappointed because the method that you had on Monday, oh, I'm down with that. We use that all the time in physics. And then what you're doing on Friday, you're doing physics. This one here is not one that we spend a lot of time with in physics, but it's important. So the method that you did on Monday, the method of undetermined coefficients, as just exemplified in that quiz, is very nice and easy to use. That is, you see the form of your G and you just know what the form of the solution is, and then you just put it in and find what the constants are. That's pretty simple. but it doesn't cover every case. It only covered 3 cases, right? Polynomials, exponentials, and sinusoids. So for everything else, that's not going to work. And so if that doesn't work, then we have to go to the variation of parameters to solve other problems. So I have like 3 slides on the theory. So first, you find your homogeneous solutions. So you have y1 and y2 are the homogeneous solutions. Remember from everything you've learned so far with homogeneous equation, you say, okay, my solution for the homogeneous equation is a linear combination of those 2 solutions. Well, here we step our game up a little bit. Instead of saying it's a linear combination of it, we're going to say it's some unknown function times y1 plus some unknown function times y2 is my complete solution. So I've added 2 functions. And because I added 2 functions, I'm actually allowed to put in a constraint. I don't know, I'm not a mathematician. I spent some time trying to figure out why I'm allowed a constraint. I'm allowed a constraint. And so if I take the first derivative of this equation, of course you have the product rule that you have to use 2 different times. So you have 4 terms. And we just arbitrarily, and by arbitrarily I mean to make our lives easiest, we say I'm going to make my constraint equation that the 2 terms that have derivatives of my unknown function add up to 0. Right, so this is the complete y prime, but I'm going to make a constraint that these 2 add to 0. Now what that allows me to do is I now have an equation that I can use to find what u1 prime is in terms of u2 prime, y2, and y1. Now, of course, that wouldn't be enough to solve anything in and of itself. So, with this constraint, the second order differential equation, we start with the whole a y double prime plus b y prime plus c y equals g. Simplifies, and I'm not showing the work for this because I knew I wouldn't have a lot of time. It simplifies to just an equation that has first derivatives. Of course, it just has first derivatives in u's because we made the terms with first derivatives in y prime were 0. So we just have first derivatives in u prime. So now I have 2 equations with 2 unknowns. My unknowns are u1 prime and u2 prime. So what do you do if you have 2 equations, 2 unknowns? Yeah, Nathan is in statics class right now, so he says matrix, and that's what we do. We make a matrix, so we have u1 prime in the first column, u2 prime in the second column, and then the answer. So we'll have, we put this one on top, y1, y2, 0, and then y1 prime, y2 prime, and gut. Do the row reduction echelon form, and boom, out comes. Of course, you can't do this on your calculator because it's functions. But we do that method, and what it gives us is equations for u1 prime in terms of y2, so u1 prime in terms of y2, g and the Wronskian, and u2 prime in terms of y1, g and the Wronskian. Now we just integrate that thing, and we're done.
Is that all?
Yeah, that's all. That's all. So we just put in, after we've integrated, y is equal to this, and the problem is complete. Wow, I only took like 5 minutes for the entire theory. I'm a physicist. What do I care about? I care about where the rubber meets the road. I care about being able to do the problems. So, and I know Daniel or Eric, excuse me. Huh?
I didn't get it. Could you go back?
Daniel is our kicker. Dan Carlson. Anyway.
Close enough.
Yeah. I will give you time to write down. So just tell me when it's time. And I do have the steps summarized in the slide coming up. Okay. So Steps to solving a problem. First, find the homogeneous solutions. You've been working on that for a couple of weeks, right? Second, put your second order differential equation in the form of this. You need to have A is 1, okay? Problem 4, I didn't think about that, and my answer was 4 times too large, and I was like, what in the world? I mean, this is all perfect math. Well, except for I didn't make it A is 1. So you need to put it in this form so you can find what G is. Then you calculate your Wronskian, and then you integrate. Those are the steps. Just four steps, as long as number 1 is considered one step to you now. So now for the rest of the class period, we model how to do. By the way, I did upload this to Moodle. Yeah, no, that's good.
You mean slides?
Hmm?
You mean slides too?
Yeah.
Okay.
Yeah. So let's do some problems. Any questions before I start doing problems? Anyone? Julie? Okay, so I'm going to refer back to this slide periodically. I thought about trying to figure out how to put something on that screen so I could have it always showing on the screen, but I haven't used this classroom except for teaching you guys 2 times in the past. So problem number 2, that's part of your actual homework. It tells us for problems 2 and 4 to solve them the new way and the old way. So let's go through our steps with problem 2. So y double prime minus y prime plus y. All right, so what's step 1?
Factor the right side, so it becomes r minus 1.
First, I'm putting that out. Don't want to start with going beyond that. So I just took the homogeneous solution. I replaced y double prime with r squared because of the factoring out stuff. Replaced y prime with r. Replaced y with 1. Had to keep the factors out, so that's why there's a minus and a minus 2. And homogeneous, so equals 0. And then we go to what Eric, I do know your name.
R minus 2 times r plus 1.
Now, probably most of us are familiar with this, but just to make sure we're all clear on the topic, if the constant number there is a negative, you're going to have opposite signs, right? If it's a positive, they're going to be the same sign. If it's a positive and the middle one is negative, they're both negatives. If it's a positive, middle one's positive, they're both positives. Just to help you at least get those down. And you can check through because it's a negative, the bigger number is the negative. So we have r minus 2 times r plus 1 equals 0, which means our roots are, and don't forget, you're setting r minus 2 equals 0, therefore r1 is equal to 2, and r2 plus 1 equals 0, therefore r2 equals minus 1. Because oftentimes we forget to flip the sign when we move it to the other side of the equal sign because we're going fast. So we found our roots. So now I know y1 is equal to e to the 2t, and y2 is equal to e to the minus t. Okay, so that was step 1. I found my homogeneous solution. I found the 2 solutions that I need to linearly combine. That's as far as I need to go. Part 2, arrange my differential equation so it has a 1 multiplied by y double prime. Fortunately enough, it already has a 1 multiplied by y double prime, and then I identify my g is equal to 2e to the minus t. And when we do problem 4, then you'll see why it's important. And problem 9. Problem 9 is not part of the homework, but I want to do it as well. Okay, so I have done steps 1 and 2. Now I calculate the Wronskian. How do you calculate the Wronskian? It's been a while? I don't know. Well, I just did all of chapter 3 yesterday, so it hasn't been a while for me.
Determinant of y1, y2, y prime, y1 prime, y2.
Okay, that's the Wronskian. And we're using it for every problem here, so I became really adept at it real quick. Nathan, question?
Just go to the left a little bit. Just so you can see what's over there. More. Just want to see the.
What do you want to see?
Well, the original problem.
It is problem 2 in your textbook as well, which is the first of the homework. The first 2 are your actual homework problems. Number 9 is not. So if I calculate this, that's going to be e to the 2t, 2e to the 2t. That's y1 and y1 prime, e to the minus t, minus e to the minus t. That's y2 and y2 prime. And so following our, since it's a 2 by 2, we just do this minus that. So that's going to be minus e to the, no, it's e to the 2t times e to the minus t. You add the exponent, so it's just e to the 1t. And then this one here is 2 e to the t. And of course, at this time, I really hope I'm not making mistakes. I worked it last night and I was really tired. And now it's the morning and who knows, I might still be making mistakes. Okay, so we have the Wronskian. We only have 2 steps left. Now we calculate, come on, scroll down. We calculate u1 is equal to minus the integral of y2g over the Wronskian. So notice u1 has the minus sign. I made that mistake last night too. Don't forget the dt. Y2 was e to the minus t. G was 2e to the minus 2. The Wronskian was minus 3e to the t. Multiplying everything through to get the simplest looking form I can. That's going to be equal to 2/3 integral of e to the minus 3t dt. This looks familiar. And I left my papers somewhere else. Great. Anyway, we'll see if I'm making mistakes, right? What's that integral? For exponentials, you divide by the derivative of the exponent, assuming it doesn't have a polynomial in the exponent or something, it doesn't have a t squared.
It becomes 2/9.
Okay, man, I hope nothing feels familiar. It doesn't feel like I'm doing it wrong, it just doesn't feel familiar. Okay, so there is my u1. Now I need to calculate u2. This one has a positive sign, y1g dt over the Wronskian. So that's integral of e to the 2t times.
Oh, wait a second. Did we forget to add the negative on the at the end there? where we split up the 2/3, there's no negative in front of it. Should there
Because there's two negatives.
There was a minus here and a minus here. Is that what you're saying?
Oh, I see.
Yep.
Wait a second.
What did I do?
Because you have e to the 2t
Yeah.
times e to the negative t times e to the negative t. So you have e to the
Divided-
2t minus
Oh, right,
you have
right,
e to the 0, which is just 1.
right. Good. At least that feels more comfortable, like what I did yesterday. Yeah, that's correct. Thank you for correcting me. Equals minus 2/3 t plus c2. Okay, so now we found our u1 and our u2. The final step is just to put it together. So if I put this together, I'm zooming out so I can see everything at once. I'm going to have y equals, so I put u1 minus 2 over 9 e to the minus 3t plus c1 times y1 e to the 2t. So there's my first one, plus u2 minus 2/3 t plus c2 e to the minus t. Now that's my answer, but of course I'm going to simplify it. So how do I simplify this bad boy? Well, let's multiply the e's through. There's one more thing I should do here. Well, rearrange it, yes, but I'm also going to contract it. If I were to factor, I'd have e to the minus t plus some random constant minus 2/9. Obviously, I can absorb.
the 2/9.
That's right. So that's what I meant by contracted. That constant can absorb the 2/9. So this is equal to c1 e to the 2t plus c2 e to the minus t minus 2/3 t e to the minus t. Question, John? Or Eric? All right. Now we have to check this against doing it the way you learned on Monday. So the way you learned on Monday, of course, the homogeneous solution, this stuff here is exactly the same. And then you say, well, my solution, e to the minus t, e to the minus t is already used as one of my solutions. So that's where s can't be 0. So I try s equals 1. Can I have t e to the minus t? Yes, that's unique. And so doing it by undetermined, whatever it's called, I'm obviously not going to have time to do the next problem, so I'm just going to write down here. So doing the undetermined method, capital Y is equal to a t e to the minus t. Well, already we can see, hey, that is the same form. It's just to make sure a is the right number. So now we take y prime is equal to a e to the minus t minus a t e to the minus t. Y double prime is equal to minus a e to the minus t minus a e to the minus t plus, oops, yeah, that's right, plus a t e to the minus t.
minus 2a.
Well, minus 2 plus t a e to the minus t. So now we put it into our original differential equation. So I would have y double prime, and I have to go back, minus y prime minus 2y should equal my g of 2e to the minus t. So I'm going to have if I were to have factored this one, it would have been 1 minus t a e to the minus t. Minus 2 a t e to the minus t. And now we just need to solve for what a is. Notice everything has e to the minus t. Since I'm not going to have time as infinity, it's actually perfectly legal to divide it out. And I have a times t minus 2 minus 1 plus t minus 2t equals 2. T plus t minus 2t, that's really kind of important that those add out to 0. And I have minus 2 minus 1 is 3. So a is minus 2/3. And so if we look back at my solution, that's what a was. So there I've done it both ways. I'm totally sorry I don't have time to do the next one or the next two. Number 4, once again, you could have solved it easier the way you did on Monday. But you do have to remember, divide everything by 4. So g is equal to 4e to the t over 2. I forgot to do that. I had g is 16e to the t over 2.
Specifically so that there's only 1 in front of the y double.
That's right. That's why. Yeah, you need to find g with 1 in front of the y double prime.
So you just have to divide it out if a is bigger than 1.
If a is multiplied by anything, or if a is not 1,
A is not 1.
then you divide by a. And of course, you'd have to do the same in number 9. Number 9, the reason I was going to do that is because secant is not one of the functions you could do with the method from Monday.
You wish we already shift to the right a little bit.
Yeah. Okay, class is over. Have a great hump day.
Oh boy.
Get back up.